Hello, in this section we will learn how to use the tables for the superheated vapor region. First, let's recall where the superheated region is in the TV diagram, let's say. So in the TV diagram, we should know where, or we should remember where the superheated region is located. So this is a TV diagram. We recall that the superheated region is located to the right of the vapor dome. So this is the superheated region. It's located to the right of the saturated vapor line, so to the right of the saturated vapor line, and also it is above the critical point. So here also, here's the T critical, so it is above the critical point. So that is the location of the superheated region. So the table for the superheated vapor is located in A4, and as you can see, the properties of V, U, H are listed for under values of temperature and for different values of selected pressures. So let's say here at a pressure of 5 bar, the first row here corresponds to the properties of the saturated vapor. So at a saturation temperature, T saturation, which is stated here between the parentheses at T sat, for example, equal to 151.86 degrees Celsius, the values for V, U, and H are given for each saturation temperature, and the saturation temperature will change from one pressure to another. So the first row always correspond to the saturated vapor conditions in each pressure table. So this for the first row is VG and UG and HG. Okay, and S, we said that later on we will talk about S, which is another important property called the entropy. So let's first try to determine what are the conditions for a state to be in a superheated vapor state. So conditions for superheated vapor state. So when we can say that the substance is in a superheated vapor state or is located in the superheated vapor regions. So the first condition should be that the pressure is lower than the saturation pressure for a given temperature. So this can be simply proved in a PV diagram. So if we draw a PV diagram, and this is a vapor dome, We know in a PV diagram we draw lines of constant temperatures, and they have a downward trend, as we said before. So this line is for a constant temperature. The pressure for the phase change during the phase change process, it's called the saturation pressure. So in order to be in the superheated vapor region, we should have a pressure. So this is the saturation pressure. Should have a pressure lower than the saturation pressure for a given T. So if P is less than saturation pressure for a given temperature, then we can say that the pure substance is in a superheated vapor state. So another condition, so condition 2, a temperature that is higher than the saturation temperature for a given pressure P. So this is simply can be shown in a TV diagram. So if we draw a TV diagram and we draw lines of constant pressure, so this is P, and the temperature during the phase change is here the saturation temperature. So if we are in this region, we have a temperature that is higher than the saturation temperature. So for T higher than the saturation temperature, the state will be a superheated vapor state. Also, if we have V specific volume greater than Vg, or the internal energy greater than Ug, or H greater than Hg, then we can say that this is a superheated vapor state. So if we draw the TV diagram, for example, so here is Vg. So any volume, for any specific volume that is higher than Vg will, or for internal energy also, or for enthalpy, if it is higher than the Hg or Ug or Vg, then we can say that this is a superheated vapor. The last condition, for if T, for any pressure, if T is higher than the critical temperature for any given pressure, also we can say that we are above the vapor dome. For example, this is a TV diagram. So this is the critical temperature, and let's say we have a pressure here P. So if the temperature is here higher than the critical temperature T, higher than the critical temperature, we are above the critical point, then we can say that the state is a superheated vapor state. So let's solve a small example to determine a property using the table. Let's say we have water at a pressure P of 5 bars and a temperature of 200 degrees Celsius. Okay, so what we can do first is to know in which region this state belongs, to which region this state belongs. So first we can go to the pressure table, and look at a pressure of 5 bar. At 5 bar, the saturation temperature is 151.9 degrees Celsius. So the saturation from table A3, we can say, at a pressure of 5 bars, the saturation temperature is equal to 151.9 degrees Celsius. So the temperature here, T, which is equal to 200 degrees Celsius, is higher than the saturation temperature, which means that it's a superheated vapor. So it is a superheated vapor. So if you want to locate the state on a TV diagram, so this is a pressure of, let's say, 5 bars, and the saturation temperature is 151.9 degrees Celsius. So we have a temperature of 200. So we are to the right of the saturated vapor line. So here is the location of the state on a TV diagram. So in order to know, let's say, we should find the specific volume and the internal energy for this point. So we go to table A4 and we look at the pressure of 5 bars. At 5 bar, here, as you can see, the saturation temperature, you can find it from this table. The saturation temperature is 151.86 or 0.9 degree, approximately 0.9 degrees Celsius. So 200 is higher than the saturation temperature, and we can read the values for the specific volume, 0.4249, and so it is 0.4249 meter cube per kilograms, and the internal energy will be equal to 2642.9 kilojoule per kilogram. So we have used table A4 for finding the properties U and V.